Hey guys, welcome to this module 4 of basic engineering mechanics. Let's see the learning outcomes. So first of all, we'll state the Newton's first law of motion you can recall from the basic physics class, and then we'll try to express the 2D and 3D equilibrium equations for the particle resulting from the applications of the Newton's first law of motion, and then we'll learn about a graphical tool that we can use to find the equations of static equilibrium for a real problem, and then we'll try to find out laws for drawing the free body diagram, and we'll sketch a free body diagram for a particle. Okay, so let's get started. So the Newton's first law of motion states that a particle originally at rest or moving in a straight line with a constant velocity. That means the particle is at rest or the particle is moving with constant velocity will remain in that state when not subjected to any unbalanced force, and that condition is called static equilibrium. Okay, that condition is called static equilibrium. So in the static equilibrium of equation says the sum of all the forces acting on a particle should be zero. That means the particle is at rest. The sum of all the forces which are acting from any direction should be zero. So in 2 dimensions you can write that sum of all the forces working on a particle in x direction is equals to 0, and sum of forces acting on y direction are 0. Or this is the Cartesian coordinate system you can write in terms of parallel or perpendicular systems. So that will give you two independent equations, and in terms of 3-dimensional object you can write this thing as the sum of all the forces which are working in x direction are equal to 0, sum of all the forces working in y direction are equal to 0, and sum of forces working in z direction is equal to 0. So these are the conditions for a static equilibrium of a particle. Okay, now we'll try to use this condition of static equilibrium to find the free body diagram. So there are some basic steps to find out the free body diagram. So first of all, we have to identify the particle or the body of interest. So if you look at this figure, this point, so from this point there are three things happening. There is a cable which is running towards the left at an angle of 40 degree. There is another cable passing through same point running towards right at an angle of 50 degree, and there is a weight of 10 pounds. So if I draw this point here, okay, draw this point here, so we are taking this point as a point of interest because all the cables, all the tension is passing through this particular point. So from this point, now the next thing we'll do, we'll try to sketch the particle which is free from constraints. That means we'll disconnect this particle from the entire world and we'll think of it is in air. So now we'll apply the external forces. Okay, so towards right, in terms of cable, we have a tension. Okay, so we have tension, suppose T1 we applied here. Towards left there is another cable, so we will mark this thing as another tension T2. Okay, and again towards down there is a weight of 10 pounds, 10 lb. Okay, now the last step is to add the dimensions. So dimensions we have is the angle. So angle is towards the right is 50 degree and towards left is 40 degree. So this is the basic procedure to draw the free body diagram of a particular system. Now these free body diagram can be very useful to find the equations of static equilibrium for any real world problem, and that will be very helpful to you all. Okay, so I hope you get a clarity about this thing, and the more you get to know about the free body diagram, the more you will be able to apply the equations of static equilibrium. Okay.